We are going to do several different examples of rationalizing the denominator. With these examples, we want to get rid of the square root or the cube root, whatever the root is in the denominator. So in this first one, the square root of 5 isn't cutting it, but if it was a 5 squared inside the square root or a 25, this would work. So I'm going to multiply in what I need, and that's another 5. But whatever I do in the denominator, I've got to keep this guy balanced. I need to do that also in the numerator. As I multiply these through, radical 5 times radical 5 is radical 25 or radical 5 squared. Super nice. They undo each other. In the numerator, because these are the same root, they're both square roots, I can multiply what's on the inside there. So I'm just going to write this as 4 times 5, but you can just write that immediately as a 20. So I end up with 3 radical 20. In the denominator, I've got a 5, just a 5. So in the denominator, I've got a 5, and this is my final answer. Let's go ahead and take a look at another one. This next example here has variable as well as the 3 inside that square root. So I want to multiply by, since this is a square root, I want everything squared inside the square root. I'm going to multiply by the 3 times the a. We'll see some that aren't square roots and things change just a little bit. So I'm multiplying by that radical 3a, numerator and denominator, to keep this guy balanced. In my numerator, there's nothing to simplify. The 2 stays on the outside, and I've got radical 3a. And then in my denominator, I'm just going to write this as the square root. You could multiply this all out if you wanted, but I'm just going to leave this as the square root of the quantity 3a squared. This is really nice because I know that the square root undoes that power 2, and I end up with a 2 radical 3a for my numerator and a 3a for my denominator. No more simplifying that I can do, and this one is my answer. Let's take a look at another example that doesn't have a square root. So in this first one, I'm looking for a cube root. That means that whatever I've got inside this cube root needs to be something cubed in order for me to take the cube root and basically get rid of it. Well, the 2 isn't big enough, so what I really need is a 2 cubed or an 8. I already have 1 2, so I need to multiply by a 2 squared. Similarly with that x, so the x is just to the first power. I need 2 more x's to get this to be an x cubed. So I'm going to end up multiplying by a cube root of, I've got 1 2, I need 2 more, so that's going to be a 2 squared. I've got 1x, I need 2 more, so that's going to be an x squared. Whatever I do in my denominator, I do in my numerator as well, so 2 squared, x squared. Okay, let's simplify what we can now. As I'm simplifying, nothing really that I can do with that numerator other than just rewriting it. So it's 5x cube root of 2 squared is 4, and then I'll leave the x squared. In my denominator, I have a cube root, and I've got 2 to the third. I've got a single 2 and then another 2 squared. So that's going to be 2 cubed. And then I also have an x and an x squared. That's going to be an x cubed. Well, that's great because this cube root undoes these powers of 3, and I end up with our simplified answer. So I've got 5x cube root of 4x squared. In my denominator, I took that cube root and I've got a 2 and an x. In this next one, I actually have a 4th root. So I want to start by breaking this 9 down. The variables actually turn out to be really, really easy. Well, the 9 is already something squared, right? The 9 is 3 squared. So as I think about what I need to get to these 4th powers, I need to multiply in another 3 squared. So let's go ahead and rebuild this one. I'm going to actually rewrite it first using powers. So I've got the 4th root of 3 squared x squared y. Remember, my goal is to have 4th powers up here. So as I multiply in a 4th root, I have 2 3's, I need 2 more, so that's going to be a 3 squared. I have 2 x's, I need 2 more, so this is going to be an x squared. Here I've got a single y, I need 3 more to get to that power of 4. In my numerator, I do the very same thing. So this is going to be 3 squared x squared y cubed. Let's give ourselves a little more room here as we finish this off. So if I've done everything correct, I should be in really good shape. Let's go ahead and write that numerator out first. I've got the 3 on the outside, and then I've got that fourth root. 3 squared moving inside here is 9. So I'm going to write that guy as 9. X squared y cubed. In my denominator, let's go ahead and combine all of these here and make sure we've got fourth powers on everybody. So in that denominator, I have a fourth root of, I've got 3 squared, that's 3 to the fourth. I've got x squared, that's also x to the fourth, and then y to the first, y cubed, that is y to the fourth. So this is exactly what I needed. My fourth root can undo those fourth powers, and I end up with my answer. So I've got my 3, this is my numerator, fourth root of 9x squared y cubed, divided by, the fourth root is gone now, so divided by 3xy. I've got one more. In this one, I have a square root of 12 in my denominator, so I know I need something squared. I could multiply in a square root of 12 here, but I really want to use the simplest possible radical, so I'm going to simplify this radical 12 first. A perfect square does divide into 12. 4 goes into 12 3 times. So I can rewrite the square root of 12 as the square root of 4 times 3. I can take the square root of 4, that's equal to 2, and then I'm left with a radical 3 in my denominator. So let me rewrite what this looks like. So in my numerator, I've got those two terms, negative 3 minus radical 2. In my denominator, I've simplified this a lot. The square root of 12 is equal to 2 radical 3. That means I just need to multiply by another radical 3 to get rid of the square root in the denominator. Whatever I do to that denominator, I need to also multiply in by that numerator. And I'm going to put that numerator here in parentheses. So writing what we've got, we can distribute this radical 3. So I get negative 3 times the square root of 3, and I get my negative there in the middle, and then radical 2 times radical 3. That's going to be the square root of 2 times 3, or 6. In my denominator, everything is just multiplied here together. I've got a 2 times a radical 3 times a radical 3. So this is going to be 2 times radical 3 squared, which is perfect because I can undo the square with the square root, and I end up with my rationalized form. So I've got radical 3 minus radical 6 divided by 2 times 3. To finish this off, I am going to just multiply out that denominator. So in the numerator, negative 3 radical 3 minus my radical 6, nothing to simplify there, divided by 6, and this is my rationalized answer. In the next video, we are going to rationalize things that have 2 terms in the denominator, so take a look at that video next. Thanks so much for watching.